Hey everyone, welcome back to the Web Security Bootcamp channel. In the last video, we covered the basics of SQL injection, signed up for PortSwigger Academy, and set up Burp Suite Community Edition. If you missed that, don't worry, the link is in the description. One quick reminder before we dive in, this is for learning purposes only. Please don't test these techniques on real websites, only safe labs like this one. In this video, we'll take our first hands-on look at a real SQL injection vulnerability. You'll learn how to detect if a site is vulnerable, understand how the attack works, and use a simple payload to retrieve hidden data from the database. In this series, I'll be using Kali Linux, but you can follow along on Windows, Mac OS, or any Linux distribution. Here's the lab we'll be working on today. I've included the link in the video description so you can try it yourself. This web application normally displays only products that have been officially released. However, there's a flaw in how it interacts with its database. Our goal in this lab is to exploit that flaw by manipulating the database query so that we can also view the hidden, unreleased products. Before we start testing, let's quickly recap what SQL injection is in simple terms. SQL injection happens when a web application takes user input and puts it directly into a database query without proper validation. This allows us, as attackers, to modify the query and make the database do something it wasn't supposed to do. In our lab, the website asks the database, select from products where category equals gifts and released equals 1. Our goal is to change that query so the database returns all products, including the hidden ones. This is exactly what SQL injection allows us to do. Okay, let's get everything set up. I'm running Burp Suite Community Edition. In the free version, the only option is Temporary Project in Memory. This means all data is stored only while Burp is open and will be lost when you close it. Click Next. Keep the default setting, use Burp Defaults, and click Start Burp. Now go to the Proxy tab. Notice that Intercept is disabled by default. Click Open Browser to launch Burp's built-in browser and arrange the windows so the lab page and Burp are both visible. I've opened the lab in the browser and Burp Suite is running in the background. When I click on a category like Gifts, the request is sent through Burp, and that's where we'll do our testing. Click on any category, I'll choose Gifts. Here, what we see by default, only the released products are displayed. Let's count them now so we can compare results after our test. There are just 3 products on the page. Now here's our payload, single quote plus or plus 1 equals 1 dash dash. Let's break it down. The single quote closes the text string. A string is just text wrapped in quotes like gifts. The plus plus is just a space, or adds another condition. 1 equals 1 is always true, and makes the rest of the query a comment, so the database ignores it. Altogether, this forces the query to return all products, not just the released ones. Now let's check if this application is really vulnerable. First, enable interception in Burp. Refresh the lab page so Burp can intercept the request. Find the Get Request and select it. At the bottom, you'll see the intercepted request. This is where we can make changes. I'll replace the gifts category value with a single quote. Quotes like single quote or double quote are often used to test for SQL injection because they can break the execution of a query if the application doesn't validate input or use parameterized queries. Click Forward to resend the request and then disable interception. When we send this request, we immediately get an internal server error, a serious warning sign. This usually means our single quote has broken the SQL syntax. The query probably looked something like this. Select star from products where category equals quote, 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 and released equals 1. Our extra quote closed the string too early, leaving another unmatched quote. The database couldn't process it, so the server threw an error. Those 3 quotes in a row confused the database. It only expected text inside 1 pair of quotes, but we accidentally broke the query. This is a clear sign of a SQL injection vulnerability. To confirm, let's use a simple payload. We close the string with a single quote, then add 2 dashes to comment out the rest of the query. The new query would look like this. Select star from products where category equals quote, quote, dash, dash. Now let's test our payload. Go back to the previous page. Turn interception on in burp again and select a category, in my case, gifts. Find the get request once more. Replace the category value with our payload. And click forward. This time the syntax error disappears and the application responds normally, but the results are now based on our injected input. This confirms that the application is vulnerable to SQL injection. Next, we'll go beyond testing and perform a full injection to retrieve the hidden products. Now let's perform the actual attack. Go back to the previous page. In Burp Suite, I intercept the request. Find the parameter category equals gifts and replace it with our payload, single quote plus OR plus 1 equals 1 dash dash. Then I forward the request. Back in the browser, the page reloads and look at this. The number of products displayed has increased. We now see both released and hidden products. At the top, there's even a message saying, "Congratulations, you solved the lab," which confirms that our attack worked. Let's quickly count the products on the page. Clearly, there are more than before, which proves our injection was successful. And here's a challenge for you. Write in the comments how many products you see after the attack. I'll be checking and waiting for your answers. Now here's how the payload works. The single quote closes the text string in the query. Or 1 equals 1 is always true, so the database returns all rows. And the double dash comments out the rest of the query, preventing errors. That's why the application now shows us everything, including the hidden products. This vulnerability is dangerous in real life. Developers can prevent it by using parameterized queries, validating and sanitizing input, limiting database permissions, and testing applications regularly. Let's summarize what we accomplished in this lab. First, we tested the application with special characters like the single quote, which triggered an internal server error, a strong sign of vulnerability. Then we confirmed our suspicion by using to close the string and comment out the rest of the query. Next, we launched the full payload single quote plus or plus 1 equals 1 dash dash, which forced the query to return all products. As a result, previously hidden items became visible. The main lesson here is clear. Applications must sanitize input and use parameterized queries to prevent SQL injection. Thanks for watching. If you found this video helpful, be sure to like and subscribe for more beginner-friendly content on cybersecurity and ethical hacking. And don't forget to check the video description for all the links we mentioned. If you have any questions or suggestions, please write them in the comments. See you in the next one.